We're going to talk briefly about Newton's second law here, and this explains how much things accelerate by. So if you remember, Newton's first law explains why something accelerates or why something changes its velocity, and that's if there's a net force on it. Newton's second law quantifies that. It says, if there is a net force, how much does something accelerate? So it does this by comparing the mass, the net force, and the acceleration. So we compare these three values and we get a relationship. And we get that the acceleration is equal to the net force divided by the mass, which is much more often presented as net force equals mass times acceleration. But I like introducing it like this because this shows a bit more logically what's going on. If I apply a certain amount of force and it has some mass, here's how it's going to accelerate. This doesn't make much sense because it's really saying if I want to accelerate by a certain much and I have a mass, what's my net force required? So this right here, again, sigma is net force, and it just means add up all the forces together. The acceleration, you'll notice here, mass is a scalar quantity, net force is a vector, acceleration is a vector. So acceleration will always be the same direction as the net force. So if I have a force going like this, and then another force going like this, and another force going like this, and another force going like this, then the net force is going to be something like that, and it's going to accelerate that way. This only applies to net force. You can't use for individual forces. So you can only talk about the total force acting on an object. So back to this example here, I can't say this force produces an acceleration upwards, this force produces an acceleration down to the left, this down to the right, this to the right, therefore the total force is to the right, the total acceleration is to the right. So we can't calculate these individual accelerations and then add them all together. Technically that will work mathematically, but it's going to cause you problems because there is only one net force on the object. There is only one way that the object accelerates. It's not like it's accelerating in all these directions and then this one wins out. It is only accelerating to the right here. But what we can use it for, and we do use it for, is components. So what we can do and what we will do is say we've got a force like this. Then I will talk about how much it's accelerating to the right and how much it's accelerating upwards, because those are presented then as the components of its acceleration, not individual accelerations added together. So I want to really distinguish that. We don't use it for the individual forces, but we do sometimes use it for components because it's clearer that components are part of a larger whole and they're just a thing to make the math easier. If you do it for these forces individually, it has that risk of making it look like you're doing something that technically isn't described in reality, even if it may be useful. If you have questions about that, let me know, but otherwise this is the basic idea. The rest of what you work on will be kind of playing with it and getting comfortable with it.